Well, folks, big night tonight. We're going to cover all of our probability review. So we've covered at least, at most, exactly permutation versus combination and some other crazy stuff in here tonight. Take your time. This is our last huge review, and we'll look forward to seeing you tomorrow. All right, this probability goes with the words at least, at most, and exactly. Now, this is the formula we're going to use for binomial probability, and again, this is only for at least, at most, exactly. NCR, probability of a success to the R, and then the probability of a failure to the N minus R. Okay, this is not given to you. You have to memorize this. Now, to be more specific, the N and R here, we want to see this in your notebook here in blue. These represent the trials. This is not your probability. This is your trials. N is the total number of trials. R is how many you want to happen. Okay, then comes the success and the failure. Notice the other thing to catch is what this is an R, then this side is an R. These two should match. And then this is to the difference of the N minus R. So let's go ahead and dive into our first problem. Now again, you don't need to copy all these words down. We can just read it and set it up together. The probability of winning a particular carnival game is 1/6. If Samuel plays the game 5 times, which of the following is closest to the probability that he will win exactly 2 of the 5 games? So I don't have the multiple choice there for you, but we are going to set it up anyway. So the key word that you need to underline, or at least write in your notebook, is the word exactly. That right there tells you NCR, probability of a success to the R, probability of a failure to the N minus R. That's what gave this formula away. Now let me stress again, these are your trials. How many times are you going to try this? Well, if Samuel plays the game 5 times, which of the following is the closest probability that he will win exactly 2 of the 5 games? So I'm going to play a total trials of 5, and I want 2 of them. Okay, now comes my success. I want to win. What is the probability that we win the game? Well, that was 1/6. Okay, now notice these have to match, so this is going to be to the second. If you win 1 out of 6, you fail 5 out of 6. And this is to the N minus R. This is to the third. Another thing to note is that these exponents should add up to the total number of trials. Now, I want to play with how we're going to answer this question, because a lot of us get the answer and then we screw up exactly how to answer it. So let me tweak some of the words here. If I said to the nearest hundredth, okay, we plop that in our calculator. I'm getting 0.160751. And if I said to the nearest hundredth, I'd go 10 hundredth. Look to the number to the right. I would say my final answer is 0.16. Okay. If I said, if they didn't say you could round, all right, if the problem had no rounding in it, okay, then I would certainly go on my calculator, math, frac, and see what it tells me. It wants it as a fraction. And I would say that's 625, hopefully you're doing this along with me, over 3,888. Lastly, here's the one that got most of us on our practice grizzlies there. So every now and then they'll say to the nearest, let's say 1/10 of a percent. Okay, so a couple things we have to get out of that. First of all, it does say nearest 1/10. But you're not rounding the decimal to the 1/10. You are rounding it to the nearest 1/10 of a percent. So what would you do to get a percent? Well, if I had 0.160571 on my calculator screen, and it wants a percent, hopefully you would just hit times 100. Okay? And then I would get 16.075, blah, blah, blah. And now this is what I'm going to round to the nearest 1/10 of a percent. I would say 16.1%. So be real careful whether it wants a decimal, a fraction, or a percent. Pay close attention to the italics, and that will tell you what to round to. Question 2. A family has 3 children. Assuming the probability of having a boy and girl are equal, which of the following is the probability that there are at most 2 girls in the family? So again, the key word that sticks out to me is the word at most. At least, at most, exactly is our formula NCR. Probability of a success to the R. probability of a failure to the n minus r. Okay, and again, when I see that at least at most exactly, I know I can use this formula. Okay, so I would just want to stress that the trials come first. Trials. Says, which of the following is the probability that there are at most 2 girls in the family? Well, 2 out of how many? How many trials or how many children did they have? Family of 3. So I would say this is 3C2. Okay, again, those are your trials. Now we're changing gears. What is the success in this case? You want to have a girl. All right, so be smart when you answer this question. How many different ways can you be a girl? Hopefully you're saying 1 out of 2. Either you're a girl or a boy. And this number stays to the second, and if it happens 1 out of 2, it fails 1 out of 2 to the first. Now, if it said exactly, I would be done there, but it says at most. Okay, so think about this. If the most you can have is 2, okay, that means you can't have more than 2. That is the most. What else could you have? Well, I hope you would say you could also have 1 or none. Now, the thing we got to catch is between these, we have to see a plus sign on your exam paper. We don't care if you add them without it, it's got to be there. Okay, whoever's grading your paper needs to know that you added those together. My probabilities will not change, just the trials. So this will be to the first, and this will be to the second. Okay, so again, the probabilities don't change. You're still a girl, 1 out of 2 ways. Just the trials change. And now lastly, I would take this number, store it into alpha A, alpha B, alpha C. And then on my paper, I would add A plus B plus C and get my final answer. Okay, so I'm going to assume we can do all that. My goal today was just to focus on that setup and the difference between at least, at most exactly, and the probability you'll see next. Alright, in the next few examples, we're going to switch gears from at least, at most exactly to different types of probability here. So the next question. Some of you may have seen this on one of our Grizzlies already, and some of you may have not. A 4-digit serial number is to be created from the digits 0 through 9. How many of these serial numbers can be created if 0 cannot be the first digit, no digit may be repeated, and the last digit must be a 5? So that's a lot to take in. So first of all, I just want to talk about options. To determine this answer, it's all about our options. And the first thing they told me was a 4-digit number. So I kind of draw out 4 blank lines. And again, I just want to talk about our options. We have the numbers digits 0 through 9. Well, think about it. If 1 through 9 is 9 digits and you add 0 to it, we actually have 10 digits. Okay? And again, I'm thinking options. It says 0 cannot be the first digit. So all I do underneath is I put like a 0 and a slash through. I know that can't be 0. No digit may be repeated, and the last digit has to be a 5. So I know this has to be a 5. Now remember, back to the word options. If this last digit has to be a 5, how many options do you have to put there? Well, again, if it has to be a 5, that's 1 option. Now I'm going to come back to this first digit. This can't be a 0. So you might be thinking, there's 9 options then. Well, that's not true because remember, you can't repeat. And you've already used the digit 5 here. So this can't be a 0 and it can't be a 5. So I actually have 8 options. Okay, now think about the next digit. There's no rules here. All you know is it can't be whatever these two were. It can't be whatever number I used here, and it can't be the number 5. So if you think about that, you still have 8 options because you've only used 2 numbers. And then if I go to my next place here, I've used a number here, a number here, a number here. I don't know what they are, but I know I've used 3 numbers, so I would say I have 7 options left. And again, in this answer, I'm just going to multiply each of these. And hopefully we get an answer of 448 options. In our next example, most people are pretty comfortable with this, but we'll go through one anyway. It does say which expression, and I killed the multiple choice here, represents the number of 8 different letter arrangements that can be made from the word Savannah if each digit can only be used once. So this is that time we use that factorial. So it goes total factorial divided by your repeats factorial. All right, so let's just start by counting up Savannah. 1, 2, 3, 4, 5, 6, 7, 8, I would say. So on top goes 8 factorial. And feel free to cross them off as you go. I'm looking for anybody that repeats, so I see 2 n's. So that's 2 factorial. And it looks like I see 1, 2, 3 a's. So that's 3 factorial. Now notice, everything's being multiplied. They're going to try to trick you and put a plus sign there. Make sure you know everything's being multiplied. Now our biggest mistake is the type of calculator we have. If you have that updated calculator, you're hitting alpha y equals for that fraction button. If you have that nice old TI-83 calculator, you're doing it in steps. You're putting this in your calculator and you're writing your answer down. I've got 40320. You're putting this in your calculator and you're writing your answer down. Divided by 12. Now you're typing that in your calculator and determining what your answer is. And I've got 3,360. So again, this is a pretty simple question. Just be careful, those of you with that TI-83 calculator. All right, now we get to the tough part of the day. Permutation versus combination. When to use which? All right, so let's start with permutation. This is when the order matters. Okay, and there's keywords. If you're talking about position, okay, position on a baseball team or a soccer team, placement, placement on a bookshelf, placement on your table. Then I'm going with permutation. Combination, order doesn't matter. Keywords are committee or team. Okay, if you're just selecting a random team or committee, that's a combination. So notice like those P words, position and placement are permutation. Committee and team are combination. So you don't need to draw this out, but I just want to be clear. The term combination lock is mathematically confusing. To open such a lock, such as your locker, the order of the digits is important. So this really should be called a permutation lock. Okay, the name of it is very misleading. The order matters, so every combination lock you open is actually a permutation lock. So example 1. From a club of 28 students, a president, vice president, and treasurer must be chosen. And how many different ways can this be done if no student can serve in more than one position? Okay, so you've just got to mentally ask yourself, are they giving me position and placement, or do they want a committee or a team? And that's your key every time. Well, if I say the words a president, a vice president, and treasurer, hopefully that jumps out at you as a position. Those are positions people hold. So I would say this is a permutation. Okay, remember, the total number goes first. What you want goes second. The larger number has to come first. There are 28 total, and I have a president, vice president, treasurer. That is 3 positions. So 28P3, again, you're just typing this in your calculator, math, probability, and we've got our answer. So I'm just going to work on the setups tonight. Mr. Wheeler's math team must choose 4 of its competitors to compete in a group question. If the team has 12 members, how many different 4-member groups could he form to compete? So is he talking about positions or placements, or does he want a team, committee, etc.? Which one is he describing? He needs to pick a 4-member group. Did he label any positions or placements? I don't think so. Team, committee, team is like a group, I would say. So I'm going to go with combination. So I have a total of 12, and we want a group of 4. And again, just throw it in your calculator. The next big detail we have to pay attention to in probability is the and versus the or. Okay, the and in probability means to, multiply. And the or in probability means to add. All right, so we're going to have to get those in our head. And is to multiply, or is to add. All right, next example. A bag contains 12 marbles, which includes 7 red marbles and 5 blue marbles. That's a total of 12. We reach into the bag and we pull out 4 marbles. Question A. How many different sets of 4 marbles can be pulled from this bag? By different, we literally mean different marbles regardless of color. Okay, so do we have position and placement, or are we just pulling out 4 marbles? So I don't see anything about the words position and placement. I just want a total of 4 marbles. So it said regardless of color. I don't care what the color is there. So I have a total of 12 marbles. Remember, total comes first. Okay, this is a combination because there's no position or placement, and it says we want to get 4 of them. So I would just throw my calculator, 12C4. Okay, now comes the great regions question. How many of these sets contain 2 red and 2 blue? How many of these sets contain 2 red and 2 blue? So again, this is still a combination because the order doesn't matter. And to me, that word that's jumping out is and. So that's telling me I'm going to multiply 2 things. Okay? And I've got 2 combinations coming, but I know I'm multiplying because of and. Now, specifically, you need to write one for the red. So I'm going to make a note. This is about my red, and this is about my blue. So I'm going to scroll back up here. There is a total of 7 red and a total of 5 blue. So I have a total of 7 red and a total of 5 blue. Totals come first. And then what I want comes second. I want 2 red and I want 2 blue. Okay, so again, total, want, total, want. One is about red, one is about blue, and is telling me to multiply. Now again, you can type that all in on one line and you've got your answer. The next question is very, very similar. I'm tweaking it by one word. So let me go back and read B. B said, how many of these marbles contain 2 red marbles and 2 blue marbles? Part C says, what is the probability that these sets contain 2 red marbles and 2 blue marbles? The only difference in the word is probability. Okay? Now, probability, again, is what you want over the total. What I want over the total. So, what I want is what we did in part B. I want 2 red and 2 blue. Now I need to get my total. Okay, so again, what I want was 2 red and 2 blue, so I wrote my 2 combinations about that. Now comes the total. And it's very simple. Another combination. What is the total number of marbles? And it's very simple. Just add your totals. I would say 12. And what's the total that you want? Well, again, we'll add those totals. And now you've got your answer. And this number probability should be a number less than or equal to 1, between 0 and 1. Let's stick one more part to this question on here. Part D, how many of these sets contain all red marbles or all blue marbles? Okay, did you catch that word or? This time that's telling me to add my 2 combinations. Okay, so again, watch that and verse or. So I have 2 combinations. The first one says all red. Okay, so what's the total amount of red? Was 7. And if I want all of them to be red, that would be 4. Okay, again, total, want, plus, I want all blue, and we said there's 5 blue, and we would want all of them to be blue, so 5C4. Total, want. And again, this time I'm just going to carefully type that in my calculator and make sure that I add them together. Well, last example here. Harold draws 5 marbles out of a bag that contain 12 red and 10 blue. Which of the following calculate the probability that Harold draws 3 red, 3 red and 2 blue? Okay, so right off the bat, that word and is telling me to, hopefully you've said it, multiply. Okay, do I have a permutation or a combination? Are they giving me position and placement, or am I just grabbing some marbles? Hopefully you're saying combination. Remember, totals come first. I need to pick red and blue. So this one's going to be about red. This one's going to be about blue. I have a red marbles. I have a total of 12, and I want 3. Blue marbles, I have a total of 10, and I want 2. And now because it says the word probability, I'm not done. All right, I've got to divide by the totals. So the total would be 22, and the total wants would be 5. And hopefully you can see right there that that's choice 2. And we've got an answer. So I know it was a lot of probability for tonight. We tried to cover all that we can here. And we'll see you for some castle learning tomorrow. Have a great night.